The first person I would like to introduce onto the stage is the Vice President of IASP, Mr. Josep Miquel Piqué.
Good. Thank you very much. I am so happy to be here. And you know why? Because we're connecting today in Barcelona two incredible moments. In 3D, as you know, the best and the more important event on 3D printing in the world. We are here today. But today we had a wonderful opportunity to connect another world, the world of the academics. Today we had at La Salle University, La Salle Ramon University, the opportunity to give the honor of the Doctor Honoris Causa to Vint Cerf, the father of Internet. And the two things were the same day. It was really incredible. How can we take advantage of this moment? Talking with organizers, and we were talking, okay, let's go to put together, let's go to connect the two worlds, and let's go to enjoy together what we were doing here, because at the end of the day, we are talking about innovation, we are talking about transformation, and we're talking how the new startups and the big corporations are learning how to transform our future. This morning, during all this morning, we had 22 new startups talking about new materials, software, factory machines, and also applications on health, retail, automotive, and other sectors. It means we had this morning a wonderful opportunity to listen to the new startups. But on the other hand, we have just listened how HP is doing innovation. We need both worlds. And you know that at 8 p.m., we will have here the awards, the first awards of in 3D. These awards will deliver the best company coming from more than 300 startups from the world for every single category. If you want to discover what companies we were providing, we were listening this morning, you can download this slide. It's very easy. You go to the QR, you put the photo, and you will see, if you want, this is a real time. What you can is to download this ebook. With this ebook, we start the first white book of in 3D. We want to create every year the best 22 companies of the world that are telling us how can we transform sectors like health, like food, like automotive, or like retail. But this is one of the parts of this morning. After that, we had the opportunity in parallel to provide and to give the honor to Mr. Vint Cerf to be Doctor Honoris Causa of our university. For this reason, I would like to invite the person that was nominating. At the end of the day, was the person that was applying for this Doctor Honoris Causa, Andrea Bea, as you know, digital champion of Spain from the European Commission, and also some people say that he's the biographer of Internet. He knows everybody in Internet, and I understand that you have to start the creation of the new history of Internet, of the print and the printing 3D.
Thank you. Thanks, Josep. Good afternoon, everybody. This is Andreu Bea. As he said, I have an impossible mission. It's called Digital Champion, which means to push the administration, the public administration, the companies, and also the citizens to become digital. And this is an army of one, so it's myself, and I'm trying to push all the population here in Spain. We are 26 of us, one in each country. And today, this is not the important thing. The important thing is that all our lives has been changed by many people, but especially one person who is Vint Cerf. I would like to introduce you to him because he's a very humble person, but a very important person in your life, because he changed everything when he created the Internet, him and his colleagues. So, Professor Vint Cerf.
Thank you.
Okay.
Thank you very much.
Vint, if you want, we can start this dialogue because, you know, you are the father of Internet.
Well, I'm one of them. You know,
one
there's
of them.
more than one.
You can have more than one father in Internet. That's good. And you discovered 50 years ago how Internet could change the world. And now you see here that we have a new kind of technology. What is your first reaction when you look at this kind of new the dialogue between bits and atoms.
So my first reaction when I walked into the building was, wow, this is really terrific. And the reason I was so excited about it is that what you're seeing all around is the beginning of new infrastructure that will allow us to do things we couldn't do before, just like the internet allowed us to connect computers together and to use them to do things we couldn't do before. So the first reaction I had was, wow. The second reaction I had was, how can I connect all these machines to each other and make them work together? And so I started thinking, what do you do next when you have the ability to create objects with the 3D printers? Now, each of you know that in order for that to happen, somebody has to send the instructions to the printer to say what it is supposed to do. So that's sort of like the blueprints. What's interesting about that idea of sending the instructions to the printer is that if other people can see those instructions, then, and if they are allowed to work with them like you can with open source, we can start to learn from each other how to make the 3D printing do new things. And it's like the World Wide Web. All the browsers let people who were looking at the web pages see how they did it. You could ask the browser, show me the HTML that made this web page. And so all the webmasters learned from each other how to make more interesting and more useful web pages. Same thing can be true for the 3D printing, but there's a next step. Even if you can print the parts, what about putting all the parts together? Now, mostly we have to do that, but wouldn't it be interesting if the next step is robots that have instructions for assembling the things that the 3D printers are making? So now we're making a step closer to more advanced manufacturing that's happening on a distributed basis instead of being centralized manufacturing. So my first thought is, okay, let's get all the machines interconnected. The second one is next year, when you do this, I want some robots on the floor assembling the pieces.
That's good, good. We're talking about how can we put connection bits and atoms, but we need to put these bits on the cloud. And this is something that is very interesting because we are coming from a digital world. And you, as a champion of digital Spain, do you think that the cloud is ready for that? Because we were thinking until now to digitalize things that we can download in a digital world. But how can we advance in this dimension of the cloud as a platform all of our life?
Well, that's a good question because you are reversing everything right now. Because we were going from scanning to the digital world, then to the cloud, but now we are going from the digital world again to atoms and again to things. And the first wow reaction that we both had at the entering was thinking, there is each booth they had a different printer. Probably they are proprietary. Probably this one is one brand, the other brand. And you were thinking, how we connect this? Because this sounds familiar. In 1969, when the ARPANET was born, exactly, we had the same problem. There were so different machines, DECnet, IBM, HP, Unix. They were isolated islands. And thanks to the protocols and the TCP/IP, they now all work together, all the computers talking the same language. Here, probably each of the printers we can have a look here, they are totally proprietary and they don't talk each other right now, I think.
So let's try an idea here. We know that there are CAD/CAM systems that help you do design. And so it would be nice, and I assume it must be true, that some of those systems know how to send information to the 3D printer to make what you designed. There used to be an exhibition in the US that was called Interop, which stood for interoperability. And the rule there was if you brought a piece of equipment to the Interop show, you had to connect it to what they called the show net, the Ethernet, and demonstrate that you could interwork. So the obvious next thing to do is to get the network running, or maybe we use Wi-Fi, and show that the CAD/CAM systems can talk to different of the different printers, and maybe also show that you can get the same system, CAD/CAM system, driving more than one printer, because the parts that you need to make might be special purpose. But this printer knows how to work with this material. That printer knows how to work with different material. So now I'm starting to get different parts, all from the common design system. And then the next problem is the robots pick up the parts and they put things together.
So you are suggesting an interop for printers?
Well, more than just the printers, though. That's the point. I mean, let's make the ecosystem. Let's demonstrate that there can be a 3D printing ecosystem that goes all the way from design to production of the parts to assembly. Mm-hmm. If you ever see the video on YouTube of the Tesla assembly plant in Fremont, California, there are 160 robots that are taking the parts, which for all I know are coming from at least computer-controlled devices. They may not be 3D printers, but these giant robots are assembling the Tesla cars. And that's the kind of thing that would be fabulous to demonstrate in an exhibition like this.
Mm-hmm. In this way, when we talk about 3D printing, we're talking about voxels, but we were starting with bits, after that with pixels and the screen, 2D dimension, and now voxels. One of the challenges of any industry when it's starting, as you say, is the problem of the standards, or the problem of the common standards. I don't know if the best is the standard de facto or is standard because they tell you how you have to do. What experience you can share, or can you share with us about the process of standardization, or how did you create these standards on internet? Because at the end of the day, you had the same problem. You had that every factory was creating, or every company, their own vertical solutions, but they didn't have, and you had to make dialogues between IBM and other kind of companies. What kind of orientations this industry can really take advantage of internet as a process of standardization?
Well, let me remind you that there is another ecosystem that's in evolution now called Internet of Things. And we have the same problem there. We have manufacturers making these devices that are programmable. They can communicate over the internet, but they don't necessarily talk to each other because we haven't agreed on all the standard ways of allowing those devices to tell us, what information they're gathering, or to accept controls and commands. Standards have this great property. Once everybody agrees on the standard, we don't have to have one-on-one negotiations to make things work, because if you agree with me on the standard, then I know when I speak in a standard way to you or to you, it works, instead of having to make a negotiation with 1,000 different companies. So standards are really great for making efficiency. Some people will say, well, the standards somehow inhibit innovation. There are some cases where that might happen, but most of the time in the space that we're working in right now, standards encourage innovation because they guarantee interoperability. So you don't worry about that part. The part you worry about is the application that sits on top.
Okay. Do you want to add anything about the standardization?
Oh, well, sure, because I heard that the woman who is designing such a nice shirts and t-shirts and whatever, she was saying, well, when I arrive to the hotel, then I can print my dress and I dress it. And I was thinking,
Are you planning to wear a dress at the hotel?
Not for me, but I was thinking, is she carrying by herself the printer, the huge printer? Because otherwise I don't see that the hotel has the proper printer to print her dress. Okay.
Okay, good. And let me go forward because, here we have machines, hardware, here we have software, here we have materials, and they are ready to be used. At the end of the day, are ready to apply any kind of innovation. But the problem is not us. The problem is the adoption of this technology. One of the challenges that we have in this kind of industries is the applications in order to find the killer application, or at the end of the day, the innovation in health, in automotive or whatever, because we're changing the way of printing, at the end of the day, the way of manufacturing. When we talk about innovation, and in your experience in Google, how do you stimulate innovation in a big corporation? Because I know that all entrepreneurs here are very innovative. They have only time and a very small piece of money in the pocket. Time and energy. They don't have a lot of money, but they have energy. But the problem of the big corporations is that if you have a salary at the end of the month, and how can you stimulate the people in Google to make innovation in order to adopt and to discover new applications? And sorry for that.
So the first observation is that we don't have to stimulate very much. The people at Google are filled with energy and ideas and everything else. In fact, we know that. We know that there are 62,000 people at Google now. We started out with 2 in 1998, but we grew really fast. The thing that they recognized is that the engineers are going to be distracted about 20% of the time trying stuff out and exploring ideas. That's what engineers do. And so they said, okay, let's just build that into the business model. We know that the engineers are going to spend 20% of their time just exploring ideas. We can't stop them, and we don't want to. So we made it official. We said, at Google, you have 20% of your time to try whatever you want to try out, as long as it's not illegal. So we actually allow the innovation to happen. We don't have to force it. I will tell you a story, though, about a man named Steve Jobs. I'm sure you all know that name. He was the owner of a company called Pixar, in addition to being the CEO of Apple. And after Pixar's most successful first full animation movie, Toy Story, they had enough money so they could build a new building. And Steve was trying to figure out, how can I create conditions where there will be a lot of casual interaction among the employees, because it's the casual interaction that generates the ideas. At Google, we have a rule. No engineer should be more than 50 meters away from caffeine and junk food. And so we have little micro kitchens scattered all over the place where you can find something to drink and something to eat. And so the engineers are there and they talk to each other. So Steve Jobs was trying to figure out, how do I create this condition at Pixar? And he had this great idea. He put all the toilets in the middle of the building. And so if you had to go, you had to go to the middle of the building. Now, most of the time when you're on the way in that direction, you're not paying attention to anybody else.
Yeah.
But after you go the other way, now you're relieved, and you can talk to people. And so his idea was that on the way out, people would run into each other and they would have these conversations. He also made one other rule. Some of you know, when you are doing a movie, you create a company and you make a big secret. No one is going to know what is in the movie. And so this portion of the company is isolated from the rest of it. And Steve hated that idea. He said, you're making a movie and you run into a problem. You want every bit of talent you can get. And so he wanted anybody in the company to be able to work on the movie if there was a problem or a challenge. And so he said, I don't have any restrictions. And so by making this building so people could interact with each other, Andreo, I can't figure out how to make the hair on this, on this horse look real. And so, do you know anything about rendering hair? And Andreo might say, oh yeah, I had to do that with a different movie. Sure. And so this whole idea of allowing people to explore their ideas is important. Now, make one other point. At Google and other companies where innovation is valued, you are allowed to try things out even if it doesn't work. Okay, so we are allowed to fail. We're not encouraged to fail. They don't say go out and fail. But they're saying try things out, and if they don't work, it's okay. But please learn from that. Okay, don't make the same mistake over and over again. So this idea of permission to take risk is really important. And the idea that that it's not fatal if you take the risk and it doesn't work, that's really important, and it really stimulates the creative feelings at Google.
Andrew.
I just want to add one point that you said, well, we have materials, we have the printers, we have the infrastructure, but you forgot to say something. We have the people. Here, probably in 10 years, all the people here who came over, who gathered for this event, will be the pioneers of this new sector, because this has changed the world. But probably most of the people didn't notice. The world has changed, and this will change a lot. And we are part of this revolution, and you guys are the pioneers. You don't find the right tools yet. You are 2 hours waiting for your printing, your render, whatever. This will be done like that in 10 years or less. And then the good thing is that you are creating a network. Coming over here, it's doing something that you probably don't notice or don't value, but you are creating this network. And the best network you can do is a network of people, a network of pioneers. And it does not be a surprise that in 5 years, you will be the CEO of something that is printing, probably in a job that you had never even imagined that you can do that. And this is the important thing, to be here to fill the network. And please take business cards, give business cards away, and really be assured that the world has changed, and it will change more. For instance, as an example, our grandmas, of all the people here, and maybe our mothers, were makers. All of them were makers. 100 years ago, most of the dresses were made by the mother, not by the father, but maybe by the grandma. Most of them were makers. Now we are very cool. Oh, we are makers, you know. But think about it. 100 years ago, everybody was a maker. And now we are makers, but armed with right tools and incredible tools that can create and can, once you have designed something, you can reply or multiply all this creation. That's amazing. It has never been in the history of humankind. This has never happened before. You were saying that you have a rendering of his body, and you can copy it, and right? And he's giving these little statuettes to the friends, to the co-workers, and this is mine.
You know, just to amplify this a little, this company makes these little statues. You stand on a box, and they have a special camera, and they go all around you, going like this. And then about 2 weeks later, they send you this little statue in full color. And it looked, if you know anything about the Egyptian history, when the pharaohs were buried, they had these little statues there. They were called ushabti. That means answerer. And the idea was that when the pharaoh enters into heaven or wherever they went, that these answerers were there to respond on his behalf. So my little statue is on the desk of my staff. And so even though I'm traveling 80% of my time, they know I have my eye on them all the time.
I'm looking at you.
Good. We go to the last question before to open the dialogue with the audience, and I will need a micro just to be sure, but you have to be near us, okay? About community of developers, because you were stimulating innovation inside the company. It means that you have people stimulated at the end of the day, but you are taking advantage of the innovation of the world. You are taking advantage of the energy of the world. But this is not easy. How can you connect the energy of coming from entrepreneurs with the community of developers? At the end of the day, you are creating platforms that are not just for you. You are opening this platform in order to take advantage of people that will work with your platform. That is a really very interesting approach, but how are you developing this strategy?
So, well, I'll give you a very concrete example of a successful development. At Google, we developed an operating system called Android, and we gave it away. We said, you're free to use this if you want to. If you choose to use Android, it has some standard application programming interfaces associated with it, which means that all you need to know is what the application programming interface says. You don't need to know about the details of the operating system, And you don't need to know how does a mobile work. You just need to know how to program above the API. And so this is a way of triggering collaboration among a large number of people, because now they all are sharing a common platform. What that means is that sometimes they may cooperate with each other to develop applications. Maybe they move from one company to another, but if they already know that particular operating system and the API, they are useful immediately to the new company they go to. So the idea of harnessing people's willingness to collaborate and cooperate is very, very powerful. And in the ecosystem that you are developing for 3D printing, this kind of collaboration might actually turn out to be quite powerful. Some people might specialize in certain kinds of 3D printing capability, other people in a different specialization. If I'm a manufacturer of products or the designer of products, it's really great to know that I can go to multiple parties using the same standard language, so to speak, to get those various pieces made. And so the community can actually reinforce itself if it uses this notion of open source and information sharing.
Good. We have the last 5 minutes, and you are in front of the father of internet. What of the parents? One of the parents. But in any case, one of the parents. For me, you are the father, and you are the
son. You are the spirit.
And if you want to take advantage of this moment to make a question, a public question, please, micro. Can you help the microphone? 1, 2, 3. That's all. Okay, because we have only 5 minutes. Very short question, and if it's possible, easy question.
Okay, I may not hear the questions very well, so go ahead.
Please come here.
Yeah.
Hi, Vint.
Come on the stage. Come here.
Hi, I'm
Tomás Diez from Fab Labs, working with the Center for Bits and Atoms at MIT for a while now.
Yeah, this way, so yeah.
Yeah, so you were talking about the fundamental value of openness on the growth of the internet. We have seen that in the growth of 3D printing as well, after the RevRap project appeared. So when you sit here and you see, these big companies like HP, which you can make the question how far they can go into opening and what they can open. So what would be your advice in trying to implement the culture of open source in a now and to really create the impact that the internet had today?
So if you are making equipment like we're seeing around here, and you want people to use it, if they have to learn different things for every piece of equipment, if you have to have a different language to control that, you're going to encounter resistance. And so some companies will give things away, hoping people will use it because they got it for free. This is the trick that IBM used, and also Digital Equipment Corporation. They would give the computer to the university. The students would use it, and they hope when the student goes to work that the first thing they think of is, I have to buy an IBM machine or a Digital Equipment machine. I don't think that's necessarily the best way to achieve the objective. The real objective is to get a growing group of people that can use your stuff. And so what you really want is as much standardization for the design work, for the CAD-CAM work, for example, and interfaces that will drive that machine. That's why it's been very important for people who make ordinary printers to have drivers that they give you, so you can not worry about how to control the printer. You use standard, Microsoft PowerPoint, or you use Word, or you use Google Docs or something else. You're working with the application. You're not worried about how to interact and interface with the device. One other point I will make is that when the internet was first designed in 1973, there were, as you mentioned, multiple proprietary networks. SNA from IBM, TechNet from Digital. Those machines could talk to each other, but within one brand. So the IBM machines could talk to other IBM machines. Digital could talk to Digital, but they couldn't talk to each other. When we offered this non-proprietary protocol, the companies that made those things said they hated it. They said, go away. We don't want the standard. We want people to be locked into using our proprietary equipment. A few years into the spread of the internet, guess what happened? The people who bought the machines said to the companies that made them, I am not buying your machine unless it can do TCP/IP, so all the machines I have can talk to each other through the network. So the consumers, the buyers, set the rules. The same thing will happen with the 3D printers. You will set the rules, or your customers will set the rules to say, we want interoperability. I want to be able to use any 3D printer with my design system. So that's where openness pays off.
Okay.
Thanks so much for asking.
Good. The time is over. It means that we have to combine this critical situation. We have two questions.
Right,
we have 1 minute.
One
Please,
more.
the two questions.
Where did the microphone go?
It's 30
Don't hurt your
seconds
leg.
answer.
Yeah, come on up.
And I
It's
know
okay.
that
Hi,
they
how
will
are
kill
you?
me if I add more one by one.
Oh, you have
my
two
life.
questions.
Okay, go.
A hardware problem.
Okay.
My question is pretty
10
quick.
seconds, 20 seconds.
If you can just summarize what you're doing for innovation for jobs. I saw you
yes,
wrote a
thank
book,
you.
and that is like, you know how we are living in Spain, and there is like big impact here.
Okay, so the short answer to
20
this,
seconds.
No, short answer is too many times we try to take a task, a job, and take this person and jam you into the job. That's terrible. You have special skills, and they're different from hers. I want to fashion the job to fit your strengths. And there might be a different job that fits your strengths. So this idea is to turn the whole idea on its side and say, let me create work that is fitted to the strengths of the people who are doing it. And it transforms the energy and ability of the company. So instead of focusing, you know how you have the annual review and they say, well, you're not doing very well with this, this, and this. Forget that. The feedback loop is you're really good at this. We need to find the right job to take advantage of that. So let's turn this on its head. That's the answer.
So we're going to organize an event in Spain, and you show
Yay,
us how.
good.
10-second question,
Last one.
20-second answer.
Yes, so
The last 30 seconds
Yeah, come
of
on
our
up. Sure.
presentation.
So our world already had some technology that completely changed and disrupt the world, such as housing, computer, electricity, phone, all those. The problem, and one of the keys seems to be the standard to allow this. Why are we still making the same mistake? And is it a mistake for you, or is it the normal process?
Well, first of all, you don't always know what should be the standard. And so when you start something new, like a lot of these things here, you do whatever you can to make it work. Okay, so rule number one, stuff that works is very persuasive. Stuff that doesn't work, you don't want to have anything to do with. So there's a period of time before you standardize where you're exploring the design space to figure out what works, what doesn't work, what works really well. We did this, we went through 4 iterations of the internet design. 4 iterations. We went through 4 iterations of the interplanetary network design. And those iterations taught us the mistakes that we were making. We learned a lot from that. So there's a period when there's exploration of things that are not necessarily going to interwork and they're not standard. When you finally get it to work, that's when you should start seriously thinking about agreeing on standards.
Okay,
so that's
thank
the story.
you very much, Dr. Vint Cerf.
Okay.
Thank you very much, Andreu. Thank you very much,
Thank you.
all of you.
Okay, we're off. Oh, we have to stay here to give away.
For you.